Get all this example with past example. Let's do one activity. What I do, if I will hit on this board like this, will some force act on my hand? Yes, I can feel some force. If I hit with some more force like this, will I hurt? Not much, but still I can feel some force on my hand. If I hit this board or wall with lot of force, will I get hurt? Yes, I will get hurt. Why? Because when I exert some force on this wall at that particular time, at that moment only, exert opposite force on my hand. So what will happen? If I apply force on anything, it will also apply same amount of force on me also. From this concept, we have our third law of motion, that to every force we have equal and opposite reaction force. So we have our third law of motion here. So with that we have third law of motion, that to every action there is equal and opposite reaction. Let's take another example. If I have a spring balance like this, and I attach this spring balance to wall, and I attach another spring balance with this spring balance, something like that. And now if I pull this spring balance in this direction, what will happen? This both spring balance will show same reading, like say 10 kilogram. Both will show same reading but in opposite direction, and this wall will also exerted by force I have exerted here. So what will happen? I exert force here, so this spring balance shift this side. At that time also this spring balance try to pull this spring balance this side. So we have both a same reading in different spring balance, and at that time also this wall also try to pull this spring balance. So we can say that for each action we have reaction that is equal in magnitude and opposite in direction. Let's take another example. If I am standing here right now and I want to move, I intend to move, what I have to do? I have to apply some force on on this earth or say floor. So if I tend to move, what I do? I apply force on earth. Let me try to explain you by figure. Consider this figure. I am standing here with happy face, and now I want to move ahead in this direction. What I need to do, I will look like this now. Something like this. So at that time, what I do? I apply some force on this earth or say this floor. I apply some force like this, some force. I try to push this earth. I try to push this floor back. And now we know that, can I move this floor back with my leg? No, I can't. So what happened? This floor also exert force on me with same magnitude but in opposite direction. So I move ahead. If floor was not that much heavy or not that much rigid, then I will not move ahead, but the floor will move backward. But we know that that cannot be happen. So when we are walking, we apply force on floor, but floor cannot move. So the floor exert same amount of force but in opposite direction. So we can move on the floor like this. We can understand third law of motion by this example also. Now here we have to understand that this force is equal in magnitude, opposite in direction, and on different object. So this force which I indicate in green pen, that is exerted on floor, and the other force I indicate with blue pen, that is exerted on my leg or say on my feet. So the force exerted on two different plane. If I hit this board, one force exerted on this board and with similar magnitude and opposite in direction force exerted on my hand. So I hope now you understood how force are work, which means force are always in couple, force are always in pair. So we have couple of force. We can take another example. Let's take another example. We have one gun that is loaded with bullet. Okay, we have one gun loaded with bullet. When this bullet fire like this, what will happen? This bullet have some velocity in this direction and force exerted on bullet is also in this direction. At that time, by third law, this bullet exert force on this gun, and magnitude of this force on bullet and magnitude of the force which is on gun are same in magnitude. So here I say F on bullet is equal to F on gun, which means F is equal to ma. I say mass of bullet, acceleration of bullet, mass of gun, acceleration of gun are same. So we know that mass of bullet is very small compared to mass of gun, and mass of gun is more compared to bullet. So here this mass is low, so acceleration will be very high. But here mass is very high, so acceleration will be very low. You see in game or in movie, or you might shoot gun in actual, that when we shoot gun, the gun force backward like this. We seen in movie. So at that time, the holder of gun moves backward. That we called as recoil of gun. What we called as recoil of gun. So this recoil force, because mass of gun is high, mass of gun is comparatively high, so we need to remember that the force exerted on both the object is same, but due to mass difference, acceleration of both object will be different. So bullet get more acceleration and this gun will get less acceleration. So I hope now you understood that force will be same, but due to mass, acceleration will be different.